Hello students, welcome to the Old Time Biometry Show. Today I want to explain how to graph variables against one another and then calculate correlations between variables. So here we have Jackie's problem, and we're only looking at the HW genotype right now because the other ones are different, they're mutants. And for the HW genotypes, we have chlorophyll A measured, PC measured, APC, and PEE. These are all concentrations of pigments that were found in these algae. Okay, so now the first thing we want is like scatter plots of one variable against the next, and then all the combinations of variables. To get those, you can go to graphs, and then there's this graph board template chooser, which is useful. And then you start clicking on the variables of interest. So, we'll click on chlorophyll A, and then I'll hold down Command and click on PC, APC, PE, and you get this nice little thing called a SPLOM, scatter plot matrix. So I'll click on that, and then here it gives it to us. It needs to be kind of resized because it's so large. There you can see it. And here's a histogram of PC. See, here's PC, 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 APC, APC, PE, PE, PE. And you can see that PC, APC, and PE are all skewed to the right. So let's try log transforming those. This is also a little weird. There's this outlier here, and that's a very large number for chlorophyll A. And I think we'll want to fix that one and kind of bring it in closer. So let's go back to the data. It's helpful to look at it here. And then let's make some new variables. So we go transform, compute variable. And for this compute variable, I'm going to have one that is log PC. And that's going to equal log 10 of PC. Okay, and then make some more compute variables. We'll talk log APC, and that's the log 10 of APC. Transform compute variable. We'll have the log of PE, and that is log PE. Like that. Okay, then remember that variable that is variant that's really large. Here is that 116. 116. So we look around and see, like, what's the next largest variable? There's a 45. There's a 47. There's a 48.5. Probably the 48.5 is the biggest. Let's just change this one to say, 48.5. So there's two of them now that are 48.5. Okay, so now we can go back and regraph. So we'll go again to graphs, graph board template chooser. And now we don't want the variables we had before. We want chlorophyll A. I'll hold down Command. The log of PC, the log of APC, and the log of PE. Click scatter plot matrix. And then we can look at what happened. This is very big, so I'll make it smaller. There we go. And you can see that they're much less skewed to the right, and then that outlier, of course, has been fixed. And you can see that this is a pretty tight correlation. This is a pretty tight correlation. This is a pretty tight correlation. So the accessory pigments are very tightly correlated with one another, whereas chlorophyll A seems looser. I don't know if that's significant or not, so we'll test for it. We'll get a significance test on the correlation coefficients. And to get the correlation coefficients, we would go to Analyze, and then down to Correlate, and then bivariate. We want the bivariate correlations from every variable to every other variable. And again, we'll put these variables in. That, good. Yeah, it's probably all right. We want a two-tailed test. Pearson's, click OK. And here we have the correlations. So here's chlorophyll A versus chlorophyll A. Of course, that's 1. And then chlorophyll A versus PC, the log of PC, is 0.45, and that is significant. So all of these correlations here with chlorophyll A are significant. And then, of course, the other correlations are also significant, like these 0.995, 998, and 0.992. Those are all significant as well. So that's correlation and the significance test for them, and then this wonderful graphing tool called SPLOM. Good night and good luck.